Now, in this video, we're going to answer the following question. Find the modulus and argument of this complex number to 2 decimal places. And we've been given the complex number -3 plus 6i. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. A complex number is a number of the form a plus bi, where a and b are real numbers, with a representing the real part of the complex number and b representing the imaginary part. The modulus of a complex number is the magnitude or distance from the origin to the point representing the complex number on an Argand diagram, and is derived from Pythagoras' theorem. The modulus is a positive real number. Finding the modulus of a complex number is a 3-step process. First, we need to square the real and imaginary parts of the complex number. Then, find the sum of those values before taking its square root. The complex number we've been given is -3 plus 6i, and we're going to call this z. The modulus of z is equal to the modulus of -3 plus 6i, which is equal to the square root of -3 squared plus 6 squared. And -3 squared is 9, and 6 squared is 36. So we need to find the square root of 9 plus 36, which is equal to the square root of 45. The square root of 45 is equal to the square root of 5 multiplied by 9, and the root of 9 is 3. So the modulus of z is equal to 3 root 5. The argument of a complex number is the angle made with the positive real axis on an Argand diagram. Finding the argument of this complex number is a 3-step process. First, we'll draw the complex number on an Argand diagram to see what the complex number looks like. Then, forming a right-angled triangle, we can use standard trigonometric ratios to find the size of the acute angle in radians between the complex number and the real axis, before subtracting this value from pi to find the argument. To begin, we're going to draw the complex number on an Argand diagram. The complex number z equal to -3 plus 6i has a real part equal to -3 and an imaginary part equal to 6. Plotting the value -3 on the real axis and the value 6 on the imaginary axis, and drawing a line representing the complex number, the angle formed between the complex number and the real axis is alpha. To calculate alpha, we're going to draw a right-angle triangle with an angle alpha and two sides marked 3 and 6. The trigonometric ratio we need to apply is the tangent ratio, and the tangent of alpha is equal to the opposite side divided by the adjacent side. In this case, 6 divided by 3, which is also equal to 2. By applying the inverse tangent function, we get a value of alpha equal to 1.1075 radians. The argument of z is the angle between the line representing the complex number and the real positive axis. By subtracting alpha from pi, we get a value for the argument equal to 2.03 radians. So the modulus and the argument of the complex number -3 plus 6i and the answer to this question are 3√5 and 2.03 radians. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.